for number 15 on the review, secant squared over sine squared minus cotangent squared over cosine squared.
Really? Secant and cotangent. Change the secant to...
Let's see. Secant is 1 over cosine. But you want to do some of these in your head if you can to see if it would even help. So if I make secant 1 over cosine,
secant might be the only one that helps.
I don't know that helps. If I change cotangent to cosine over sine, maybe not. So I'm going to put that idea on hold. Potentially there's Pythagorean identities, but nothing stands out just yet.
Since it's a minus, do you have to make the bottoms the same?
What I definitely see is all my answer choices are one term, and I'm starting with two terms. So at some point I'm going to have to get a common denominator. So I'm going to do that because hopefully something works out. So the first one needs a cosine squared top and bottom. The second one needs a sine squared top and bottom. Oh, that's maybe good news. What's cosine times secant? Does anybody want to shortcut that for me? How do you know it's 1? You're right. The secant is 1 over cosine. So cosine times secant is 1. Now again, if you need to write that out a little more, that's fine. Cosine squared times 1 over cosine squared minus, the bottom is at least all the same now, sine squared cosine squared. Cotangent's cosine over sine. Oh, this is very good news. Right? Because cosine times secant, that's 1. That's what some of you short-circuited that from the get-go. And then cotangent times sine. All the sines cancel out, and I'm left with 1 minus cosine squared. Oh, this is good, I think. What's 1 minus cosine squared? Get my handy post-it note for my post-it note identities. If you would like to ask me for a post-it note tomorrow at the beginning of the test, I will grant you one. That way you can use it on multiple pages of the test. That's what I did when I was making the key, so I didn't have to flip around. So looking at my post-it note identities, what does 1 minus cosine squared equal? Can you rearrange that first one? Sine squared, not negative sine squared. Right? If I move cosine over, I get sine squared. And that's good. Now the sine squareds cancel. 1 over cosine squared is the same as secant squared. If you work that problem a different way, that's fine. There's probably other ways to do it. Maybe even easier ways to do it. Charlotte?
How did you know multiply the cosine and the sine? Your first
Like this very first step?
Yes.
I knew that I had 2 terms to start with, and all my answers had 1 term. So this step was get a common denominator.
Okay. So you could do the same thing by say you switch this. So basically, if you put secant on the bottom, it'd just be cosine, and then have sine on the top would be cosecant. Could you do that and be a different way?
Yeah, you could have, if you changed secant to 1 over cosine, then you sort of would have jumped to 1 over cosine squared sine squared right away, which is what we ended up with. Yeah.
Can you explain how you canceled out the sines?
Right here?
Yes.
So I did the change. I know that cotangent is cosine over sine. And I knew that change would be helpful because I knew that the signs would then cancel out. Like, it's one of those things where you think about what you could do. Hopefully you can think the next step in your head to realize if it's something you should do or not. So I can change cotangent to cosine over sine, and I realize that's a great idea because the sines will cancel. Number 63. Arctan of the tangent of 4 pi over 3. Arctan of the tangent of 4 pi over 3. Let's see. 4 pi over 3 is down there. The tangent 3 trick tells me that I know the tangent of anything over 3 is going to be root 3. That's my tangent 3 trick that I have memorized, so I don't have to do sine over cosine every time. Do I need to review that tangent 3 trick? Tangent of anything over 3 is square root of 3. Tangent of anything over 6 is root 3 over 3. And then I need to figure out whether it's positive or negative. So either all students take calculus or y over x, they're both negative. Long story short, the tangent's positive in the third quadrant. And then I need the inverse tangent of square root of 3. Well, inverse tangent, I'm only allowed to look in the first or fourth quadrant. It's positive, so I know it's in the first quadrant. And the tangent 3 trick tells me that my answer is pi over 3. So I know it's over 3, and over 3 in the first quadrant would be pi over 3. All right, let's play the game.